like to present Decentralizing Privacy using blockchain to protect personal data. It is from IEEE CS Security and Privacy Workshops in 2015. And then let's get into the presentation. And here is the motivation of the paper. I have just cited a 2019 article to support the motivation part of the paper, and this website just create the privacy problem of the four companies. So here is the motivation part. These kind of websites collect data about their visitors. So first, Google just use the analytics tracking code to use the private data, and this code is used on 75% of the world's top websites. It means that when you use the famous search engine of the Google or the world's top websites, then your private data would be tracked by this analytics tracking code of the Google. So it just directly gets into the privacy problem. And the number two company is Facebook. It just gives users information to other companies. So without any uh, allow 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 or authority of the user, it just indiscreetly give users information to other companies. It means that Facebook and other companies also know and share this information. It is really big privacy problem. And number three is Redis. Redis also tracks users' activities, so companies just tracks the private data of the users, and Amazon also collects data from its smart devices. So the question of the paper is this: is it okay to collect private data from the users? Actually, to serve the good service and optimize service from the companies, some private data from the user is okay. However, not every single sensitive private data should not be shared to the companies to guarantee the privacy level of the user. So the final solution for this is the personal data management problem focused on privacy, and this paper suggests a personal data management platform focused on blockchain using focused on privacy using blockchain. So this is the motivation of this paper, and let's get into the next part. Here's are the previous work. This is not firstly started from the technological part. The government and the politics also recognize the privacy issue in storing or in managing the private data on their own. The European Commission just extends the privacy issue problem to the legislative perspective, and also Obama just suggests the privacy issue and the child privacy issue uh, by issuing the legislation uh, in front of the publics. After this legislative perspective is constructed, and then technological perspectives are extended. The number one technology in this privacy issue is just OpenPDS. Then what is OpenPDS? It is kind of returning computations on the data. Just management system does not store any raw data itself. Instead of storing raw data itself, it just returning computation computations on the data. By using that computations on the data, they can use any system or any service using that computations on the data. So any storing raw data is not necessary in this OpenPDS system. And number two technological perspective is OAuth. Easily speaking, OAuth is not returning password to access to the third party things. They just use this access tokens to get authorized and to get authenticated from the third party. So leading companies chose to implement their own proprietary authentication software based on this OAuth protocol. And number three perspective is security perspective. Um, to protect personally identifiable information, they just use key anonymity, I diversity, T closeness, differential privacy, and fully homomorphic encryption. I think these concepts is not the key things in this paper, so I just pass to describe these kinds of perspective. And number four perspective is systematic perspective. This Bitcoin is not directly connected to the privacy problem. However, paper suggests this Bitcoin because Bitcoin can transfer currency securely without any centralized regulator. This paper also suggests the decentralized privacy solvable platform. So this paper just introduces this Bitcoin as the implementation for trust computing and auditability. So these are the previous work of the privacy problem. And then nextly get into the contribution part. Then this paper, here is the contribution of this paper. They just combine blockchain and off-blockchain storage to construct a personal data management platform focused on privacy. As you see in the previous work, they just do not use blockchain and also off-blockchain storage to create this privacy problem. However, the authors just uses this blockchain technology to create privacy problem. And number two contribution is discussion. By this paper, they just illustrate through their platform and they discuss the future improvements, how blockchains could become a vital resource in trusted computing. So they just create not only the privacy problem but also the viewpoint for trusted computing using these blockchain technology. So it could be extensible when you see the discussion part of the paper. Number one assumption for the privacy is just they focuses on mobile platform. However, this assumption is not that important to us. I think this this schema in this platform could be easily extensible to web platform or whatsoever. So number one assumption is not that important, but number two assumption is important. Number two assumption is that services are honest but curious. It means that it will not deviate from the defined protocols. It means that it does not change any defined protocol, but they just attempt to learn every possible information from the protocol. So yeah, it is the definition of honest but curious. So services are honest but curious is the number two assumption. Okay, then by using this platform, what privacy issues can be covered by this platform? They just protect against these three following privacy issues. Number one is data ownership. Users own and control their personal data. Uh, the service provider has no authority to control the personal data. The data ownership is in the authority of users. So users only can own and control their personal data actually. The second privacy issue is data transparency and auditability. Users clearly know what data is being collected about them and how they are accessed. It means that users can know the data clearly. So the service providers cannot hide or conceal the fact that what data is being collected. It is clearly open to the users. And the third privacy issue is fine-grained access control. When you think of the ordinary management system, I mean, when you imagine the ordinary data management system, before users opt out, service providers can collect the private data. It means that when users sign up to the system, they just check to the agreement. If they check, hey, user can provide private data to the company, then the service provider can use the private data from the user. However, when users opt out, that means if the user check the X mark to the agreement in terms of the providing private data, then service providers cannot use the private data from the user. However, it is kind of coarse-grained access control. It takes some time to check agreement, and it is not operated fast to revoke any access to the private data. So this new platform just provides these kind of operations. At any time, users can alter the set of permissions and revoke access to previously collected data. It means that if users want service provider, hey, please do not use our private own data, then directly the service providers cannot access to previously collected data because they have no permissions to this data. So here are the three privacy concerns. So this platform can protect against these three kinds of following privacy issues. I've omitted one figure in this decentralized platform, the off-chain key value store. So once a user sends the encrypted data to the blockchain network, the key, which is the when user once send the encrypted data to the blockchain network, then the real data is just stored in this off-chain, in this part, value part. and the key part is the hash value of the pointer. So only the pointer to the real data is stored to this blockchain network. So the pointer to the data on the public ledger is key in this off-chain key value store, and the value is the real data that is stored in this off-chain repository. And the paper said that this off-blockchain key value store is an implementation of Cadmilla, but I don't know the details of the Cadmilla. So um, if you want the further information of the off-chain key value store, then just goes to the Cadmilla paper and uh, learns the concept of the distributed hash table that is form of Cadmilla. Okay. Then let's get into the deep protocol. The number one protocol is the network protocol, and the other protocol is blockchain protocol. I want to introduce this network protocol first. This paper uses the two schemas to create the network protocol. Number one is a symmetric encryption scheme. This is kind of triples. It is consisted of generator algorithms, encryption algorithms, and decryption algorithms that consist of this symmetric encryption scheme. And the second scheme is digital signature scheme. It is also represented as triples. Number one is generator algorithms, and number two is signature algorithms, and number three is verification algorithms. The details of these algorithms are not presented in the paper. However, they just said that those are implemented using ECDSA with SCCP 256K curve, and they use just cryptographic hash function H that is instanted by SHA-256 implementation. So just refers to this algorithm when you want to get into the algorithms, deep dive into the algorithms. And first one is identities. I think the key idea of this identity is a compound identity. They just combine identities of two parties. This compound identity shows the relation between two or more parties, and it is divided into the owner and guest. Owner gets the full authorities to the identity, and the guest gets the only restricted rights that is given to the owner. So owner gets the full authority, and guest just gets the partial authority in this compound identity. So here is the notation for the compound U, S of the public. It is consisted of public key U, S and public key S, U. U, S means the owner. It is the public key of the owner that is created by the signature algorithm, and this second one is the public key of the guest, and it is also created with this signature algorithm. So this U is user and S is service provider. So owner gets user gets the full authority, and the service provider gets just the partial authority, and this is the authority is decided by the user. So this is kind of compound identity of the uh, public key, and the full identity is provided as this. It is consisted of 5 keys. Also, the public key of the owner and the public key of the guest are provided, and these things are kind of symmetric signature architecture. So owners symmetric keys and guests symmetric keys are provided in this compound identity, and also they should encrypt the messages using this secret key. And also this secret key is the secret key of the user, so user can encrypt messages to store the messages in the blockchain. So here is the algorithm to generate a compound identity. User and the service provider form a secret channel between two of them, and then user execute this generator algorithm that is related to the signature. So by evoking this generator algorithm, user can make the symmetric key of the signature, and also by evoking this generator algorithm that is related to the encryption, user can make the secret key of the owner. So user can shares the secret key of the user and also public key of the user with service provider. You may wonder why the user shares this secret key for the encryption. However, for making the messages safe, also the service provider needs the secret key for encryption. So after user shares these two keys with service provider executes this generator signature algorithm to make also the public key of the guest and secret key of the guest. After that, service provider shares this public key of the guest with user. Then finally, this user and the service provider shares secret key for the encryption and the public key of the owner and the guest. So both of them knows these 3 kinds of keys to create any operation. And number 2 is about blockchain memory. Let just L be the blockchain memory space. Then it is represented as the hash table, which is from the 0,1 256 right arrow 0,1 large n, where large n is largely bigger than 256. Then this hash table can store sufficiently large documents by constructing this hash table. Assume this memory is tamper-proof under the same adversarial model used in Bitcoin and other blockchains. It means that the memory in the blockchain would not be tampered by any adversarial attacks. Then how this blockchain memory space is constructed in the blockchain network? Just imagine the transaction in the blockchain. There are various outputs of the transaction, which is the 160-bit number. So each transaction includes a variable number of output addresses. So by using that kinds of output addresses, this blockchain memory space can be constructed. The first two outputs in a transaction encode 256-bit memory address pointer. This is the construction of this part. So first two outputs in a transaction encode this kind of memory address pointer, and the rest of the output constructs the serialized document. It means that this second part of the blockchain memory space is constructed using the rest of the output. So when you think of this blockchain memory, when you look up this L bracket K, only the most recent transaction is returned. So just think of this K as the key of the most recent transaction. So just keeping this mind of the blockchain memory, then let's get into the protocol for the permissions check against the blockchain. Here is the policy part. So the authors define this notation for the policy. This policy is kind of things that user gives service a set of permissions. So by setting this policy, user can grant service a set of permissions. This is user and this is the service provider. For example, if the policy u, s is location and the context, then user can give the information of the location, and also user can give the information on context if the policy u, s is defined as this set. Service cannot subvert the protocol. Just think of the privacy issues that are created in the previous slide. There were 3 privacy issues. So service cannot change or manipulate the protocol. So this protocol is kind of policy protocol is kind of decided. Okay, then let's get into the algorithm for permissions checks against the blockchain. The number 1 step is just setting this a policy value with hash value of the public key of the most recent transaction of the blockchain. After that, if the most recent transactions addresses is not yet recorded in the blockchain memory, then just parsing this a policy air bracket a policy value. This parse function just serialized the message sent to transactions, so the users can easily find out these 3 values. One is the public key of the owner, and the second one is the public key of the guest, And the third one is the policy between user and the service provider. So here is the decision part. This is the most important part in permission checking. So when the most recent transactions public key is equal with uh, public key of user, then the return value is 1. It means that it is permitted against the blockchain. Um, the real meaning of this notation is that if the user, I mean, if the owner just permitted this policy with his or her signature, then it means that it is permitted already. And the second notation is that if the guest has signed the policy with his or her signature, and the policy value is already in this policy u, s, then it is also recognized as permitted policy in the blockchain. So the real meaning is that if user signed to the policy, or if the guest signed with the policy and the policy value is already in this policy set, then it is the permitted policy against the blockchain. So this is the real meaning of this difficult or calculated things. And next, get into the blockchain protocols. The third protocols is related with transaction access, and the second one is related to the transaction data. So protocol 3 is kind of access control protocol because it is related with this access transaction, and this data transaction is related with storing or loading data. So by executing these transaction, this can follow protocol that stores or load data in the blockchain, and also in the off-chain key value store by executing this kind of line. Okay, then first get to the access control protocol on the left. This is kind of handle access transaction. It just inputs the public key of the most recent access and also message. By parsing message, the users can get public key of the user and the public key of service provider, and also the policy set that is between the user and the service provider. So the most recent transaction, which is the T access transactions, is signed with the user, then it is permitted. So public key of the most recent transaction, which is bracketed by this hash function and also this blockchain memory, is equals to M. Its actual meaning is that, hey, blockchain system, I want to apply this new policy to the management system, so could you check this policy? Could you apply this new policy to the management system? So the protocol parsing these messages that is consisted of public key of user, public key of guest, and the policy set. So when this protocol checks this the most recent uh, access transaction, public key of this the most recent access transaction is same with the public key of the owner, then new policy schema is applied by changing this uh, hash function of the public key of the most recent transaction to this message. So this is the process of new policy is applied to the blockchain network. So when you sends the zero set to the policy user comma s, then it revokes all access rights previously granted. If you send this transaction access with a new compound identity, then for the first time it is interpreted as a user signing up to the service. So this is the process of the access transaction, and let's get into the data transaction. Okay, here is the 4 steps to create this transaction data. Once this transaction is received, a message is parsed with this parse function, and the output of the parsing is the data and the policy and read-write value. And the second one is to check the validity of the policy. If uh, if we check policy with this policy notation and the most recent transactions public key, when this check policy is true, then it starts to parse this user public key to these kind of 3 things. One is public key of the owner, and the other is public key of guest, and the last one is the policy between user and service provider. If the check policy was not valid, it returns false, then these protocols will not be continued because this policy is not that valid policy anymore. So after parsing this user's public key, then just setting this AXP with the hash value that is combined with user public key and the policy. This policy is kinds of string, as you saw before. And number 3 step is if this read-write value is set with 0, then it just commands to write the data on the off-chain key value store and stores the pointers of the data to the blockchain. This is the hash value of the data. C is data, so HC is the hash value of the data. And after hashing this data, this is on-chain and this is off-chain operation. In the on-chain, it just stores the policy with this new pointer to the data. In the off-chain key value store, just stores data that is matched with this key of hash value. So this is kind of distributed hash table structure in the ordinary distributed hash table in the off-chain key value store, So this C is value and HC is key in the off-chain key store. What if the RW value is 1? Then it just operates the read operation. Samely, uh, it just hash the data with the hash function, so it is stored in HC value. And if this HC value is already in the blockchain memory, then it just returns the DS of HC, so the the entities that issue this data transaction just guess the data by operating these operations. And here's are the privacy and security analysis. The number one assumption is that users manage their keys in a secure manner. So these keys are not uh, stolen by the malicious users. It is just stored very securely by users. Over this assumption, the three things are analyzed in terms of privacy and security. One is that only the user has control over his or her data. As you see in the protocol, if the public key of the last recent, the most recent transaction is equals to the public key of the user, then it is able to use the policy, because it is checked by the user that okay, it is permitted policy in this system. So only the user has control over his or her data. The service provider only can retrieve the data using the policy set. So user sets the every single policy set, so the service provider does not have any control over his or her data. And number two analysis is that controlling one or more DHT nodes cannot imply the raw data, because it is because that to imply the raw data, every single entities should know every keys that is related to the compound identity. Let's get back into the compound identity. As you see in this compound identity, to imply the raw data, they should know every single these keys to check the existence of the raw data. But only if controlling one or more DHT nodes, they cannot imply the raw data, because they cannot know every single keys that was shown in the previous slide. So it is the secure architecture, as you see. And the third one is limiting the exposure of a single compromised compound identity. It means that if you want to construct more secure things, then just making many compound identity to protect your private data, then it just limits the exposure of a single compromised compound identity. So it is kind of security analysis. Okay, then just gets into the future extensions in terms of the storage. Um, Currently, it is storing pointers to encrypted data. As you see in the previous slide, it just stores pointers in the blockchain network. But the author also suggests another uh, ways to securely store the private data on the blockchain. It suggests they suggest how about splitting data into shares. Uh, it is notated with Shamir's secret sharing rather than encrypting them. Using this splitting, it does not uh, encrypting data is not that necessary. So it just uses multi-party computation to securely evaluate any function. Here is the example of using multi-party computation. It is kind of voting situation. So there are private splitted datas from V1 to Vn. So this is unsafe method to use the secure data from V1 to Vn. So in S, this e-vote mechanism just add from V1 to Vn. Then if S is less than 0, then elect U1 as the final winner. And else if S is bigger than 0, then just select the election winner as U2. But this protocol is not that safe because every splitting data is just stored in one single node, and if that node is manipulated by the malicious things, then this voting function would be manipulated by that malicious actor. So just use multi-party computation to securely evaluate this function. It means that it is not just depend on one node. Every single splitted data would be spreaded to several different nodes. So select MPC, which is the subset of the entire network. So this PI is each node that gets the V1. So MPC computes this S value with allocated V1, V2 to Vn. Also, this S value of the PI is decided by summing these kind of values and broadcast this as PI to MPC. Then S would be reconstructed with this SPI value, and also this S value would be broadcasted to the entire network. And then entire network computes the S by receiving this broadcasting from every single node that is consisted of MPC. Then after getting all these S value from each node, then S value is selected to a single point. Then if this S is less than 0, then U1 is selected as the winner of the election. If the S value is bigger than 0, then U2 is selected as the winner of the election. And this is the second feature extensions, which is trust and decision making. I don't know why this concept is suddenly appear to future extensions, but the paper suggests this trust and decision making as the future extension of this privacy problem. The ordinary proof of work algorithm uh, just shows that for every node n, trust n is just proportional to the resources of n. It means that if you have more resources, then your trust is proportionally increases. The more money, the more trust you get. It is directly vulnerable to civil attacks, so it leads to excessive energy consumption and it leads to high latency. So to prevent this excessive energy consumption and high latency, uh, the authors suggest a reputation system. So it is denoted by this trust NI, and it is decided by the number of good behaviors and the number of bad behaviors. And this alpha is kind of scaling factor of this uh, function. So if the good behavior and the bad behavior is the same, then it is goes to uh, 1 over 2. However, good this good the number of good behaviors is really large than the number of bad behaviors, then this value just goes to 0, then trust ni goes to 1. When this bad behavior number of bad behaviors just much more larger than number of good behavior, then this whole value just goes to infinite, so trust ni value just goes to 0. So this is the value between 0 and 1, and you can decide this trust ni value by retrieve the number of good behavior and the number of bad behavior. This is kind of reputation system. So it takes time to earn trust in the system, so it is resistant to civil attacks. This trust is not the temporary things, because good behavior and bad behavior is not that decided fast. It should takes time to earn this trust, so it naturally resistant to civil attacks. And here is the conclusion. This platform does not require to trust any third party. It just uses the nodes of the blockchain network, and by doing that, users own and control their own data without compromising security or limiting company's ability. So users can decide the policy criteria by setting their policy set between user and the service provider, and also service providers can focus on utilizing data without overly concerned about properly securing and compartmentalizing them. So it means that service provider um, does not manage any keys very deeply. Uh, every single algorithm is already implemented in this paper, so companies does not deeply get into the managing or securing things. So, however, this paper does not validate the future works. I mean that, as you see in the previous slide, this trust and decision making future extension is suddenly appeared um, to cover the privacy problem. So I think this is not that correlated with the privacy problem. So the validation of future work is uh, needed to cover the privacy problem. And also, when you see in the previous slide, the user's key management is done in secure manner. That was the assumption of this protocol. However, the secure key management system is not that easy stuff. So for the future work, I think the key management system should be uh, done together with this paperwork. Thank you.